Today onwards we are going to start the online classes in physics. So let's go to second year, this 12th class syllabus. So in 11th, that is 12th class physics, we have 16 chapters. So let us go to what are the 16 chapters. The first one is nothing but electric charges and fields, and second one is nothing but electric potential and capacitor. The third one is nothing but current and electricity. The fourth one is moving charges and magnetism. The fifth one is magnetism and matter. The next one is nothing but electromagnetic induction. The next one alternating current. The next one is nothing but electromagnetic waves. So the next one dual nature. The next one atoms. The next one nuclei. The final chapter is nothing but semiconductors and devices. And under one more chapter we have the communication system. It is only for objective but not for the whole syllabus. So let's go to the first chapter, that is nothing but electric charges and fields. So now we start the first chapter with electric charges and fields. Let's go to the first electric charges and fields. First we want to introduce what is meant by electric charge and what is meant by field. So we know that the total universe is composed with the two types of the things. One is nothing but the matter, another one is nothing but the energy. So as per the physics, the matter exhibits the three different types of the property. We know that. So one is nothing but the physical, the second one is nothing but the chemical, the third one is nothing but related to our syllabus, that is electrical property. So see here. The matter is nothing but a combination of atoms or the molecules or the particles. We know that. So the matter is nothing but a combination of particles or atoms or the molecules. So based on the properties, the matter exhibits the three different properties. One is nothing but the physical property, the second one chemical property, the third one electrical property. So we know the meaning of the physical and chemical. Physical is nothing but if you can give a standard statements and the characterized statements based on direct visualization to the given body or the matter or the any one substance, that is nothing but the physical property. And we know that the chemical means, so whenever the two bodies comes under the reaction, that is in contact, then if you can give some statements or characteristics to that reaction, that is called as the chemical reaction. For example, if we can draw a sodium chloride into water, the chemical reaction takes place between sodium chloride with the H2O molecules. So in this process, we will give some fixed statements to the reaction. It is called the chemical properties. And similarly here, the third one is nothing but the very important property. So that is nothing but the electrical property. So what is meant by electrical? Electrical property is nothing but one of the property of the matter. What property of the matter? So this is nothing but one of the property of the matter, and which associates, one is electric field and another one is nothing but magnetic field. That means if the matter is associated with the both electric as well as the magnetic field, and also the influence of electric and magnetic field is felt on the matter, then the property is called as electrical property. Remember, this point is very important. Electrical property means the property of the matter which is associated with electrical field and magnetic field, and also whose, that means electric field and magnetic field of influence is felt on which property of the matter, that is called as electrical property here. And which causes the electrical property means, that is one of the physical quantity you have in physics, that is nothing but charge. A charge is nothing but a very important physical quantity. So this charge refers the electrical property to the matter. So here the physical is nothing but the direct visualization. The chemical is nothing but whenever the two bodies or the two compounds comes in contact or mixing together. Electrical is nothing but it depends on the charge. Right. Now let us go to the introduction to the charge. What is meant by charge? The charge is nothing but, see the definition to the charge. The definition to the charge is nothing but the property of the matter which is associated with electric and the magnetic field, and also if the electric and magnetic field of influence is felt on the matter, then the property is called as the charge. So there is a definition to the charge, and which is the symbol we are using to denote the charge. We are using the symbol is nothing but a capital Q or the small q to denote the charge. And in physics, we know that every physical quantity have its own unit. Then what is the unit of the charge? The unit of the charge is nothing but coulomb. The symbol is nothing but C. Here, the coulomb is the bigger unit, so that instead of the bigger unit, we are using a smaller unit. That is nothing but, what is the conversion? We are using 1 millicoulomb. Millicoulomb is nothing but 10 to the power of minus 3 coulomb. And another one, the microcoulomb, mu c, which is nothing but 10 to the power of minus 6 coulomb. The nanocoulomb, 1 nc, that is 10 to the power of minus 9 coulombs. And picocoulombs, that is 10 to the power of minus 12 coulombs. So here the coulomb is the bigger unit. So normally we are using the smaller units to the charge. There is nothing but the millicoulombs, microcoulombs, nanocoulombs or the picocoulombs. So there is nothing but a conversion to the smaller system to the bigger system of units. And what is the next? There is nothing but the unit. And after that, if you can go to the dimensional formula, and DF indicates here the dimensional formula. We know that how to write the dimensional formula for the physical quantity. Already we studied in the plus one syllabus in units and dimensions and measurements. Here, the charge is not a fundamental physical quantity. We know that we have 7 fundamental physical quantities. Among the 7 fundamental physical quantities, no one became the fundamental like the charge. So, we have one fundamental physical quantity, that is the current. In lower classes, we have already some definition of the current. The current is nothing but, we know that I is equals to Q by T. That is charge per time. That is the mathematical formula to the electrical current. So, from this mathematical formula, how to write the expression for the charge is nothing but Q is equals to I into T. We know that I is the current is the fundamental, its dimensions is A. And the time is the dimension of the t. So a power 1, t power 1 is the dimension formula for the charge. So the dimension formula for the charge is a power 1, the t power 1 is the dimension formula. And also, as per physics, each and every quantity may be either the scalar or a vector or a tensor quantity. So here, a charge becomes what type of quantity means, that is the nature of quantity, that is the NQ. The NQ, nothing but the nature of quantity. Here, the charge is a scalar quantity. So, there is nothing but what is meant by charge. So here, the charge definition, the property of a matter or body which is associated with both electric and magnetic fields, and if the electric and magnetic fields of influence is felt on the body, then the property is called as the charge. The symbol is nothing but the capital Q or the small q. The unit is nothing but the coulomb. Here, the coulomb is the bigger unit. So instead of the bigger unit, we are using the smaller units like the millicoulomb, microcoulomb, nanocoulomb, and picocoulomb. 1 electron is nothing but 10 to the power of minus, sorry, 1 milli is equals to 10 to the power of minus 3, 1 micro means 10 to the power of minus 6, nano means 10 to the power of minus 9, pico is nothing but 10 to the power of minus 2, and what is the dimension formula for this? A power 1, T power 1, and what is the nature of quantity? Is a scalar quantity. And what are the another units we are using for the charge is nothing but another one more additional units. The additional units for the charge is electrostatic unit, electromagnetic unit. So electrostatic unit is nothing but ESU, electromagnetic unit is nothing but EMU. So here the electrostatic unit, how to convert one electrostatic unit? One electrostatic unit is equals to 1 by 3 into 10 to the power of 9 coulombs. And one electromagnetic unit is equals to 10 coulombs. So here is nothing but the conversion for one ESU and one EMU. So electrostatic unit is very small quantity and electromagnetic unit is greater quantity compared to the coulomb. So there is nothing but introduction part to the charge. So after the charge, what is the state of the charge? Charge may be is in trust position, charge may be is in motion. So depending on its state and position, so we will classify this branch into the two types. That is nothing but one is electrostatics, another one is electrodynamics. The combine of electrostatics and electrodynamics is called as electricity. So the electricity is one of the important branch of physics. So the total electricity branch is depending on which quantity is nothing but the charge. So if you can go to the electricity, the electricity is nothing but the branch of physics which deals about charge and its properties. So here electricity is studying about charge and its property. So the branch of physics which studies the charge and its properties is called as electricity, and the electricity mainly classified into the two types. One is nothing but electrostatics and second one is nothing but electrodynamics. So the first one is nothing but electrostatic and another one is nothing but electrodynamics. See, the word electro refers the charge. We know that. Electro means the charge. Static word refers means the rest or stable. Similarly here, the electro means the charge. Dynamics word refers for motion. So depending on its state or position, electricity is divided into the groups of branches. One is nothing but electrostatics, another one is nothing but electrodynamics. If the charge is at rest, then it gives electrostatic. If the charge comes under motion or comes in motion, then it becomes electrodynamics. So there is nothing but the two sub-branches of electricity. And how to define electrostatics means? Electrostatics is branch of electricity and which studies about rest charges. Electrodynamics is nothing but here branch of electricity and which studies about the motion of charges. So there is nothing but electrostatics and electrodynamics. And now let us go to the first chapter in 12th class, that is nothing but electric charges and fields. Electric charges and fields is related to the first chapter, that is nothing but electrostatics. See, what is the actual meaning of electric charges and fields? We know that electric charge field is nothing but a producer, that means its influence is present or felt up to certain distance around it. So that region or space specifically is called as a field. So let us go to what is the properties of the charge. Here the charge, before going to electrical properties of charge, let us take what are the types of charges. If you can go to actual modern physics, the modern physics says that every body or every particle is always at the neutral state. That means its net charge is zero. If the net charge is zero, then by which process every particle or every body gets the charge.
Continue, sir.
Okay. See, when a neutral body or uncharged body gets the charge is nothing but the modern physics says that whenever any one body or the particle or an atom loses or gains the electrons, then automatically the atom or the body gets some charge. Why? Because means in the universe, the least charge, the smallest charge is nothing but charge of an electron. That is nothing but 1.6 into 10 to the power of minus 19 coulomb. Who first found the charge of electron is nothing but the Millikan's. The Millikan's is the name of the scientist. He did one very important experiment. So that is nothing but just he sent a charged particle through both electric and magnetic fields, and based on its motion he calculated the charge of electron like 1.6 into 10 to the power of minus 19 coulomb. So that is nothing but the Millikan's oil drop experiment. So the Millikan's is the name of the scientist. Oil drop is nothing but oil drop is taken as an object, that is a charged body. So based on the oil drop, just he calculated the charge of electron like 1.6 into 10 to the power of minus 19 coulomb. Simultaneously, another one more scientist, he calculated the specific charge of electron. The specific charge is nothing but the ratio of charge of electron to its mass, that is nothing but the E by M. The scientist is nothing but the J.J. Thomson. So the Millikan's calculated the charge of electron and J.J. Thomson calculated the specific charge of electron. See, what are the types of charges? The charges are mainly divided into the two types. One is nothing but the positive charge, another one is nothing but negative charge. So when an uncharged body gets positive charge, when an uncharged body gets the negative charge, is a big question mark. So the physics, the modern physics says that suppose if you can get a neutral body in your hand, then when we will say the given body becomes the positive charge and the given body becomes the negative charge. So depending on electron affinity, we know that as per the chemistry, the meaning of electron affinity. So based on the electron affinity, just we will say which type of the body is positively charged body and which type of the body becomes the negatively charged body. If any one body or an atom electron affinity is more, then automatically it gets a negative charge. If electron affinity is less, then it gets the positive charge. That means whenever if you can consider, for example, if it is a carbon atomic number is 6 to 12. Here it is nothing but atomic number and it is nothing but the mass number. The atomic number indicates the number of protons, we know that. And the mass number is nothing but number of protons and neutrons. So the sum of protons and neutrons is nothing but the mass number. The number of protons is nothing but atomic number. See, the protons have the positive charge and electrons have negative charge. We know that as per chemistry or the modern physics, if you can take any one atom consisting the nucleus, around the nucleus, all the electrons are involved in the particular orbits. How many number of protons are present in the nucleus? Same number of electrons are revolved around the nucleus in the particular orbits. That is in different orbits. So if you can see here, for the carbon, the total number of protons are 6. So 6 protons are there, and total number of electrons is 6. So its charge is nothing but -6. So the total charge is nothing but 0. That means